Good afternoon, class. My name is Dr. Raipur. This is Algebra Practice Test 1, Module 1 for chapters 1 to 3. And here's chapter 3, Inequalities. So we want to solve this inequality, which means we are going to simplify the right side by distributing number 2. We get 2x minus 4 here. And as you can see, -4 and -4, the right side gives us -8. Now we want to move things around. One easy way would be to do the following. Subtract the 2x. Subtract the 1 from both sides, resulting in this. Divide by 3. Now this is the solution, the inequality solution. This is the interval format. Notice, since x is less than -3 and the endpoint is not included, we use the parentheses. As far as infinity or -infinity, we always use parentheses. We always use parentheses. This one, the reason we use a parenthesis because it's less than. And so in order to graph it on a number line, we pinpoint -3 all the way to -infinity. Now, since -3 is not included, you have a choice. You can put a hole there or you can put a parenthesis. Either way is fine. Don't mix things up. So we put a parenthesis at -3 and all the way to -infinity is the answer. Here's a compound inequality involving the AND statement. So for this one, we're going to move the 5. That means subtract 5. And this one, we're going to add 9. So this gives us 3. This gives us 2. We divide by 2 and we get 1. And what I want you to pay attention to is the following. Whenever you have an AND statement, if you can make it look like a sandwich, that is fine. Otherwise, there is no solution. In other words, you can't say a number is, let's say, less than 1 and larger than or equal to 3. That can't happen. But in between, that works. Understand that it doesn't have an equality with respect to 1, but it does have an equality here. So here's the interval format. Here's the interval format, class. Now, on a number line, we're going to locate 1 and 3. Now, locate 1 and 3. 1 is not included. 3 is included. We can use a parenthesis here, brackets here, or we can use a hole and a solid dot and shade in between because it's between the two. This is an AND statement or inequality or intersection, we call it.
I have a quick question.
Sure.
Can you only sandwich, as in like what you just did there with the?
Yeah, the thing is, we are saying that this is an AND statement. It has to be true at the same time. So if x is, let me grab my, if x is larger than 1, at the same time less than or equal to 3, that works. But x cannot be less than 1 and x larger than 3 if we have the AND statement, or is a different story. We will look at it in a moment.
Okay, so you can only sandwich AND statements.
If you cannot sandwich it, it doesn't have any solutions.
Okay, got it. And either way, like if we, I guess, like when we're doing the test, either way, if we input the answer like that.
Yeah, either way is fine. Again, when you answer the questions, you want to see they're asking for the inequality solution, they're asking for the interval solution, or they're asking for a graph. Accordingly, answer them for 4 credit. Now, notice, my pleasure. Notice this is asking for the OR statement. This was AND, this is OR. So again, let's finish each part and see what happens. 2y minus 6 less than 4y minus 10. This one we can subtract the 4 and we get -1 on the other side. We can move the 4y, take a look, and subtract from 2y to give us -2y. -6 moves becomes +6. And now what's interesting is this. You have a negative number as the coefficient. You have to divide by -2. Anytime you have an inequality, you're dividing or multiplying by a negative number, the sign will flip over. Let's do that. And what I like to do, just to make sure this is clear to everybody, I'm going to rewrite this at the top of it as follows. Please understand this is the same as writing y is less than -1 or y is larger than 2. Why am I writing it in this fashion? Because I want to start with the smaller value first. So I want to show you that on the interval notation, y is less than -1. That means from -infinity to -1. Y larger than 2, that means from 2 to infinity. With the or statement, we use the union. So let me write that for you. This notation, which looks like a U, it's a union of event, whereas and refers to intersection, or refers to the union. So with that being the case, from -infinity to -1, so you look at -1, and again, either parentheses or a whole, because the end points -1 and 2 are not included. So you have it like that for this portion, you have it like that for that portion, which means everything is included except in between. That's the meaning of or the union. Again, I'm going to read it to make sure everybody understands. Y is less than -1, that means this portion, or y is larger than 2. So you really want to distinguish between intersection of events, union of events. We're going to continue with the inequality. In this case, we are dealing with an absolute value. And whether you're dealing with an absolute value equality or inequality, the first step is identical, which means isolation. This has been isolated for us. So let's see what happens. If the absolute value of x is less than a and a is positive, then it's sandwiched between the two values. By the way, if a is negative, there is no solution, because absolute value by definition is distance from 0. And in the worst case scenario, absolute value is equal to 0. Remember that. So with that being the case, we want to isolate this. It's been already done. Now that there is nothing else we do, because this number is positive, we're going to sandwich this between negative and positive. And you really want to remember this transition. When it's completely isolated, then you can put it in between. Now I'm going to get rid of the +3 by subtracting it from all sides. And finally, let's divide by 2. This is the answer. This is the inequality format. Here's the interval format. We are using parentheses because the endpoints are not included. And on a number line, we are going to check mark the -5 and +2. The 2 are not included, and anywhere in between is. So there are 3 ways to answer it: inequality, interval format, graph on a number line. So I'm going to repeat: inequality, interval format, graph on a number line. We look at this next example. As you recall, the first step in dealing with absolute value equality or inequality is isolation. So this is a problem. We are going to subtract 10 from both sides, everybody. Subtract 10 from 4 becomes -6. And I hope you realize it says an absolute value is less than a negative number. It will never ever happen. There are no solutions. So I want to make sure everybody understands what's happening. When we say an absolute value is less than a negative, less than or equal or less than a negative value, any negative value, the answer is no solutions. Why is that? Because an absolute value in the worst case is equal to 0. And 0 is larger than any negative number. Now we're going to continue on that thoughts and we're going to solve this case, and we notice is greater than or equal. Before even we pay attention to that, first and foremost, let's isolate, then I'm going to discuss that. Isolate meaning we don't like the +3, everybody. We're going to subtract 3 from both sides. Then we don't like 2. That means we are going to divide by 2. Notice on the left side, there is nothing but an absolute value. Now that it's completely isolated, let's see what we need to do. It says greater than or equal. If absolute value of x is larger than a, and if a is positive, then x is less than -a, or x is larger than a. This becomes an or statement as follows. Either less than or equal to negative value or larger than or equal to positive value. So take a look at this transition. Extremely important. This is how you deal with an or statement. All right, we are going to move the negative one. That means add 1 to both sides. So this becomes 3x, this becomes -4, this becomes 6. Divide both sides by number 3. So x is less than or equal to -4/3 or x larger than or equal to 2. This is the final answer as far as the solution is concerned. As always, we are interested in the interval format and a graph. So this is done. This is the solution. Here's the interval format. Interval format.
I'm sorry. I got a little lost when you did the transition specifically. I know you said pay attention to that, and I was trying to like follow you as you're going, but how did you like, can you explain that just one more time, please?
All right. First and foremost, we subtracted number 3. Then we divided by 2 and we are here. So this step is fine, right?
Yes.
This is fine. Now, anytime you have an absolute value inequality, if it's less than a number, you do a sandwich. If it's larger than a number, which is a positive value, you say it's less than the negative one. So this one, you drop the absolute value and you say it's less than or equal to -5 or greater than or equal to +5. So take a look at this statement. We follow this statement. We're going to drop the absolute value and we say it's going to be less than or equal to -5, or we're going to drop the absolute value and say it's going to be larger than or equal to 5.
Okay.
So this is the transition.
Got it. Okay. Thank you. That really makes sense. Thank you so
My
much.
pleasure. My pleasure. I'm glad to hear that. Fantastic. Now, class, now the next we're going to continue moving the negative one. That means we're going to add 1 to both sides in both cases. When you add 1 here, it becomes -4. When you add 1 here, it becomes 6. So we are adding 1, we are adding 1. This case, and this case both, we divide by number 3, divide both cases by number 3, and this is the final answer. This is the solution in final format. What is the interval format? X is less than or equal to -4/3. That means -infinity to -4/3, or means union. X is larger than or equal to 2. That means 2 to infinity. So this is the interval format. Again, inequality solution, interval format. Let's go with the graph. So we locate -4/3, and we go all the way to -infinity. We locate +2, and we go all the way to +infinity. And notice we have two ways. We can use brackets, or we can use a solid point, but don't mix them up. Just use any of them you like. Just one of them is good enough. Graph the solution to the inequality as given. As you can see, this inequality has two variables. So right away, you recognize you're dealing with a rectangular coordinate system. So to refresh your memory about what we did in our PowerPoint, if you want to graph a linear inequality as follows, for example, x plus y equals 3, it gives us 3 regions. Here's a half plane in red, here's a half plane in green, and here's the boundary line. So x plus y larger than 3 is here, x plus y less than 3 is here, here's a boundary line. So the way I'm going to approach it is to start with a boundary line. So no matter what's given to me, I will change that to equality. Step 1, change this to equality. And this is a line, we call it a boundary line, and this is a line everybody can graph. In order for us to graph this, we need 2 pairs, and the base pairs are the intercepts. So class, if x is 0, I hope you realize -2y equals 4, y becomes -2. If y is 0, x becomes 4. So this boundary line has these 2 pairs as intercepts. We are going to plot the 2 pairs and draw the line. So 0, -2, 4, 0, here's the line. Now, whenever you draw the line, you have to make a decision. Is it dashed or is it solid? Well, you go back to the question. Because we don't have the equality, it is dashed. If we did, it would be solid. So now we have the 2 half planes and we have the boundary line. Now the question is, which side is the solution? And the best course of action is to check it. How do you check it? Pick a test point. What is a test point? Pick any point that doesn't belong to the line. The easiest point would be 0, 0, since it doesn't belong to the line. So if you pick 0, 0 and test it, what happens? Here's 0, 0. So replace the x with 0, replace the y with 0. 0 is larger than 4? No, that's a false statement. Let's see what that means. Because 0, 0 gives us a false statement, 0, 0 is not a possible solution, the whole side is out, and we take the other side to be the solution, we shade the other side. So I want to make sure everybody understands what's happening. One more time. First, you come up with the boundary line. You draw with the boundary line using 2 points, preferably intercepts. Pick up a test point. What is a test point? Any point that is not on the line. Plug it into the inequality. If it's a true statement, then shade that region. If it's not, shade the opposite region. That would be the answer. All right, given the graph, what type of test is used to determine whether or not it represents a function? That's a vertical line test. I hope you remember that. Now, given the function, we want to find a couple of things. First, let's go over algebra of functions. Class, recall. Operations on functions or algebra of functions. If f and g are given, f plus g of x, that means f of x plus g of x, called the sum function. F minus g of x is f of x minus g of x is the difference function. If g of x is f of x times g of x is the product function. F over g of x is f of x over g of x. Of course, the denominator can never be zero. That's the quotient of functions. So with that being the case, the first one is asking for f plus g. Simply put, add up the f of x and g of x. So f of x is 3x plus 5. G of x is 2x squared minus 5x plus 1. Which means we can add 3x and negative 5x. We also can add 5 and 1, results in 2x squared minus 2x plus 6. It's a good practice to put it in descending order. The next one is asking for fg of 2. So we are looking at this one in essence is f of 2 times g of 2. That means plug in 2 into the f function evaluated, plug in 2 into the g function evaluated, and then multiply the 2. So this one, 3 times 2 plus 5. This one, 2 times 2 squared minus 5 times 2 plus 1. This is 6 and 5. This is 2 squared, 4 times 2, 8 minus 10 plus 1. Six and 5, 11. 8 minus 10, negative 2 plus 1 is negative 1. Their product is negative 11. So algebra of functions. Determine the domain and range. Is each one a function? The answer to the function is yes, because they pass the vertical line test. We called it VLT for short. Both of them represent a function. So what is the domain for the first guy? Remember, domain means what? All possible values of, here's the simplest definition, all possible values of x. So from here to here. And that means from negative 2 to 5, or you can say x is between negative 2 to 5. The range is the same thing, all possible values of y, whatever the dependent variable will be. I hope you see that it covers anywhere from here all the way to this point, and roughly about 2.7. So from 0 to 2.7. If you look at this one, this graph along the x-axis, if you lay it along the x-axis, it covers anywhere from here to here. If you could lay it along the x-axis, covers from 0 to 7. If you could lay it along the y-axis, it would cover anywhere from here to here. This would be the range. Finally, what I wanted to mention when we were looking at absolute value inequality, if you happen to have an absolute value, let's say absolute value of 2x plus 1 larger than negative 2. anytime you have a negative value. Is the absolute value larger than that? Always. So for a case like that, everybody, the solution is all real numbers. You write it like that, or negative to positive infinity. So if you have an absolute value larger than a negative number, for example, absolute value of 2x plus 1 larger than negative 2, the solution is always all real numbers from negative to positive infinity.